This is the first video in a series of videos to show some of the features of the programming language I've been working on for the past few years. I've been doing quite a bit of updates and changes recently, particularly to how UI gets rendered, and I guess this is sort of a way for me to not just get feedback, but to also make sure I don't get too carried away down some rabbit hole and end up leaving things in an unusable state for too long, which I've been pretty bad about doing recently. So in these first few videos, I'm going to be making a simple 2D classical Zelda clone. And without further ado, I guess I'll go ahead and get started. So the first thing I need to do is create a new project. And to do that, you can just do it directly from the command line. And so I'm just going to create the project on the desktop. So Crayon has a command line argument called generate default project. And you can just pass in the name of the project. I'm just going to call it fake Zelda. And then you can also pass in an argument called project type, and this is a game. And so it created the project, and which you can see here. Actually, I'm going to open up this in VS Code. Okay. So at the base of the project, you have this build file, which is basically just a JSON file with some metadata-y things in them. I'm not going to get too much into this in this video. Here under source, you have your main file, which is, because I said the project type was a game, it just creates a default game from a template. And this default project, it just creates a new game window with this box that, well, I guess I could just show it. So yeah, here we have a red box falling through the sky. Okay. And the way that works is it's just a x and y coordinate as these variables here. And over here in the updater, it just adds 1 to x and adds 2 to y, and then it has this wraparound by modding the coordinate with width and height, which are constants defined up here, which I can change as I see fit. The renderer is just this graphics 2D object, which has a few functions on it that can draw things. And so here it's just drawing the rectangle at the x and y coordinate with width and height of 20 with some sort of color, which in this case is this red. Okay, I guess I'll start. I'm going to keep things simple, and the first thing we want to do is to have some sort of player sprite moving around on the screen. And so instead of having these XY coordinates updated just automatically like this, I want them to update according to the keyboard input. So the first thing I'm going to do is have an if statement that just checks to see if the arrow keys are pressed. And there's a method called isKeyPressed, and I pass it in left. And if it's pressed, then I will subtract 1 from x. And then if the right arrow key is pressed, then I'll add 1 to x. So let's see what that looks like. Yeah, something like that. And then I'll do the same thing with, I'll just copy and paste this. I'll do the same thing with the up and down keys. I'll restart my program. Yeah, and so now the box moves around with the arrow keys. So one of the key characteristics of the old classical Zelda games, or really any NES game or Super Nintendo game, is the idea of the tile grid. So what I'm going to do is I'm going to create a grid. So I'm just going to say grid equals new array 2D. And I think the size of the grid on most older games was 16 columns by 14 rows. And I'm going to fill this grid with the Boolean false. So what this new array 2D is, I can define a grid kind of like this. Like let's say I want a 2 by 2 grid, I could type something like this. But this new array 2D is basically shorthand for that. In fact, I can show you what this looks like. I can just put a print statement here and run it. And so you can see here, it's there's a list of lists, where there's a list of 16 lists, and each of those inner lists have 14 falses in them, which basically is a 2D grid. I got rid of that print statement. So this false, this is going to be whether or not the tile is walkable, whether or not the player can walk on that tile. And so right now, this implies that the player can't walk anywhere, which is bad. So what I want to do is I want to reset the inner portion of the grid to true. And so I'm just going to write a little loop that, you know what, I'm going to put these the 16 and 14 into variables. Or no, I'm actually going to create constants up here. Call count equals 16, row count equals 14. And then I'll use them here. Yeah. And so then when I loop through this grid, I can just say y equals 1, y less than call count minus 1, y plus plus. Do the same thing for x. Oops, that should be row count. Okay, and then for each of those coordinates, I'm going to say grid at x, y is equal to true. And so now I have this grid, which I'm not currently using. And so what I'm going to do is, actually before I draw the player, I'm going to draw the grid. So I need another loop. And then, and I said the Boolean was whether or not the tile was walkable. So I'll say walkable equals grid at x, y. And so if it is walkable, I want to draw a tile that is green. If it's not, then I want a tile that's brown. So this will be like grass and rocks or something. And so to draw that tile, I will use the same 2D rectangle drawing function that you can see below. Actually, I need to decide how big these tiles are going to be. So I'm going to say const tile size equals, let's say they're 32 pixels wide. So since x and y are column and row numbers, I want to multiply x by the size of the tile to get the pixel coordinate. Same with y. The width and height are just the tile size. And then the color. This row is getting long, so I'll wrap the arguments. Okay. Yeah, so let's see what that looks like. Yeah. That looks good, although my arrow keys aren't working. Oh, because I have X and Y. These are being overwritten by these looping variables. So I should probably call these something else. I'll just call it player. And I'm going to use a list instead of two variables. And so this will be the X and Y coordinate. And so I need to update this. Instead of X plus or minus 1, I'll use player 0 and player 1. So like most programming languages, if you haven't noticed, Crayon also, the index begins at 0. Okay, then I update it here, player 0, player 1. Yeah. Oh, and because we should probably use tile coordinates for the player position. Down the road, that's going to make the math a little easier. And I should probably also call math.floor on these because these are going to likely become floating point numbers. Okay. The variable math is used. Oh, I forgot to import math. Okay. Import math. All right, let's try that again. There we go. That looks good, although that's way too fast, and that's because we are using 1 as the amount that we're incrementing the player position by. But since these are, since it's running at 60 frames per second, that's, if you just hold down the arrow key, you'll move 60 tiles, which is bad. So I'm going to create a variable called velocity. And I think maybe we want the player to move about 4 tiles per second, running at 60 frames per second. So the velocity should be 4 divided by 60. So I add that instead of 1. And the reason I use a floating point decimal here is because Crayon, if you divide two integers, the result will be an integer, and it'll cut off the decimal portion, like kind of like Java or C# or Python 2. So by using a floating point decimal, that makes the velocity equal to also a floating point decimal. Okay, let's see what that looks like. Yeah, that's better. Although, of course, I said that the booleans in our grid were going to represent whether or not the player should be able to walk on that tile, which clearly it's ignoring because I haven't added any code to check that. So we should do that next. So instead of modifying player coordinates immediately after seeing that the arrow key is pressed, I'm going to use temporary variables. So new x equal to player 0, new y equals player 1, and so I'll modify these variables instead of the player itself. And then before I assign these, instead of saying player equals new x, new y, before I do that, I can have an if statement to see if it's valid. And so the first thing I need to check to see is if new x, new y is even on the grid. So if new x is greater than or equal to 0 and new x is less than call count, and new y is greater than or equal to 0 and new y is less than row count, and grid at since the indices are integers, I have to say math.floor new x, math.floor new y. And so that's a Boolean, and if it's true, it's walkable, so then yeah, that should work. Yeah. All right, let's see if this works. And it does not, because the player is starting in the top left corner, and so you start out stuck on the wall. So I should probably start this in the middle of the middle of the first tile that's free. Okay, that's better. So I'm pushing up, nothing happens. I'm pushing down. Oh, the rectangle is being drawn where the player's coordinate is the top left corner of the rectangle, which lets you sort of step into the bottom wall like this, which is not ideal. So let's fix that. So if the player's width and height is 20, what I can do is I can just subtract half that. And so the player will now be drawn centered. The rectangle will be drawn centered over the player's coordinate, which will look a little better. But you'll still be able to walk into the wall just slightly, but life is fuzzy, so it's okay. Okay. So this video is starting to get kind of long, so I'll stop it there. In the next video, I'll start adding some graphics and a few more features. I'm going to post the code on GitHub, and I'm going to post the repository link in the video description if you want to check it out. And I guess I'll see you next time. Whee!